Hello and welcome to the AI Research Roundup. I am your host Alex. Today is May 27th, 2025. We're looking at shifting AI efficiency from model-centric to data-centric compression, a research paper from Hugging Face's trending list published just 2 days ago. This paper argues that as AI models process ever longer data sequences, the main efficiency challenge isn't just model size anymore, but the rapidly growing computational cost. So it proposes a shift to data-centric compression, specifically token compression. Tokens are the basic data units models use. Token compression reduces these units, tackling the quadratic cost of self-attention, a core process whose expense explodes with more tokens. This is especially true for multi-modal LLMs, models designed to handle diverse data types like text and images together. Alright, so Figure 1 really sets the stage for this shift. On the left, a graph shows context length. That's the amount of data models processed at once, exploding upwards since 2022, while model size growth has slowed. The diagram on the right then contrasts two eras. First, model-centric compression, where techniques like pruning, removing model parts, or quantization, simplifying model numbers were key. Now it's moving to data-centric compression. This focuses on the data itself, using methods like token pruning, selectively removing data units, or token merging, which combines them, to improve efficiency. Building on this idea of data-centric compression, Figure 2 presents some interesting and perhaps surprising empirical results. We see 4 sets of bar charts, each for a different task category, like complex reasoning and image understanding. These compare various sophisticated token compression methods against simple, random token dropping. And quite unexpectedly, in several scenarios, these engineered methods are outperformed by random pruning. This really underscores a key challenge, that current methods can degrade performance. For example, this can happen when compressing the key value cache, or KV cache, which is a memory area in transformers that stores attention calculations to accelerate processing. Okay, so to further illustrate this challenge with growing data, this next table details the Llama series model specifications. It shows release dates, parameter counts, which indicate the model's complexity or size, and most importantly, context length. We see a dramatic expansion here. For instance, Llama 1 handled about 2,000 tokens, while the Llama 4 Scout aims for 10 million. This explosion in context length directly impacts things like the key value cache we talked about, making its efficient management through token compression absolutely vital for handling such vast amounts of information. Following that trend with Llama, this table now details the Intern VL series model specifications. These are multimodal models, handling both text and images. We see their release dates, the LLM backbone, which is the core language model component of these systems, alongside maximum context length for text, and importantly, image resolution and maximum image tokens. For instance, early models processed images leading to about 1,000 tokens, but newer versions like Intern VL3 can handle images resulting in 32,000 tokens and much higher resolutions. This again highlights the escalating data processing needs, reinforcing the argument for data-centric compression. Continuing with multimodal models, this table details the LLAVA series specifications. We see similar trends: release dates, LLM backbone, max context, image resolution, and importantly, maximum tokens. For example, early LLAVA models from April 2023 handled 256 tokens from images. But by August 2024, LLAVA1 vision models can process thousands of tokens from visual inputs, for instance, over 7,000 for single images, and can also handle multiple images or video, generating substantial token counts. This dramatic increase in token count from visual data further emphasizes the critical need for efficient token compression techniques to manage these growing demands. Alright, so these examples, like with the LLAVA models, really drive home the central argument. The paper concludes that as context lengths explode, AI efficiency must shift from model shrinking to data-centric token compression. This is vital due to mechanisms like self-attention, where each token assesses all others for context, a process with quadratically growing computational cost. Token compression has great potential, but challenges like performance consistency and better real-world speed benchmarks, beyond just flops, or floating point operations per second, need addressing. That's our AI Research Roundup. Thanks for joining.